Hi, and welcome to this week's online discussion. In this first problem, we want to either find the limit or show that the limit does not exist. So the limit question is that if I set fxy to be x squared plus y squared to the power of x squared y squared, I want to find the limit of f as x and y go to 0, 0. So whenever you see functions with these kind of powers, a nice trick to use is to use logarithm. So notice that f of xy is equal to e to the log fxy. And if the limit of x and y going to 0, 0 of log fxy exists, so if this limit exists, then by continuity of the function e to the x, the limit of fxy must also exist and must be equal to e to the limit of log fxy. Why? Because continuity of e to the x means if xn converges to x, then the limit as n going to infinity of e to the xn equal to e to the x. So here our xn is log of fxy. Since this limit exists, it converges to something. So if I evaluate e to the log of fxn, which is this thing, and I take xy to converge to 0, continuity of e tells me that this is the same as evaluating e at the limit of log of fxn. Great, so now we just need to see if the limit of log fxn exists. So the limit of x and y going to 0, 0 of log fxy is equal to, the power comes down, so this is x squared y squared times log x squared plus y squared. Since we have x squared plus y squared here, we're basically hinted to use polar coordinates. So we transform x into our cosine, y into our sine. So this is, I'm missing a limit here. So after the transformation, x and y going to 0 is the same as r going to 0. And x squared y squared is going to be r to the 4th times cosine squared, sine squared. And log of x squared plus y squared is log of r squared. Great. So log of r squared is just 2 log r. So this is just limit of r going to 0, r to the 4th, 2 times r to the 4th log r, cosine squared, sine squared. But we know that we know that log grows very slowly in the as basically the entry goes to infinity. So we know how log behaves with r to the 4th as r go to infinity. But here we have r going to 0. So it looks like we can just do another transform. We can map r to 1 over r, so that the limit now is r going to infinity. And so we have r to the negative fourth, which is 1 over r to the fourth, and log r becomes log of 1 over r, which is negative log r. And we have here 2 times cosine squared sine squared. So now we're more comfortable with this limit of log r over r to the fourth. We know that log grows very, very slowly, and it's beaten by any polynomial. And r to the fourth is some polynomial. So this limit is going to be 0. And here in this part, we have 2 times a product of sines and cosine. But sines and cosines, they oscillate between -1 and 1. So in absolute value, this thing is bounded by 2. So this second part is bounded, and this first part goes to 0. And the product of anything that goes to 0 with anything that's bounded is going to 0. So the limit is 0 at the end. So it means my original limit, this is going to be e to the 0, which is 1.